Hello everyone and welcome back to our channel. In today's video, we are going to see how we can dump a text file from memory to deal with a technique called compression, or another fancy word for this is packer. So without wasting any more time, let's directly dive into it. If you are a security researcher or an Android enthusiast dealing with Android applications, then you must have known that Android apps needs to define their classes and different components such as services, broadcast receivers, intent filters in Android manifest file, right? But sometimes these components and classes defined in Android manifest are not visible in the decompiled source code, and that is because of a security protection mechanism called compression or packer. Such cases, the app loads the undefined classes at runtime. Let me quickly show you what I meant by this. So for this video, we are going to use a sample application called anti-split, which loads its classes at runtime. So let's directly decompile the APK in JetX decompiler tool. As you can see here, it's already extracted in the directory named textterm. Now in a separate terminal, let's go to the directory where our JetX GUI is present. And under this directory, we can launch the JetX tool using /JetX-GUI. Alright, let's open up the application. Now here under the resources, if we open the Android manifest file, we can see that we have our main activity defined over here, which is present under com.tilks.arsc.main package, right? Similarly, we have some other activities like settings activity, and then we have some services, right? So by looking at this, all our services and the activities are defined under com.tilks.arsc package. So let's expand this by going into the source code under com directory. Here we can see we have this tilks.arsc, right? And if we expand this one, we can see that we only have the R file here, which basically contains the references to all the resources. And the other package we can see is android.protector. Let's expand this one also, and here all the class names are obfuscated and the only one visible is protect application. Now of course, just by looking at this package name and this class name, we can assume that some kind of protection has been applied to protect all the classes of this application. Now the basic concept is that loading a class requires a dex or jar file to be present in the file system. Okay, so in order to do that, all the protectors extract the compressed or packed classes into a dex file, which then later can be loaded by the application using dex class loaders. And usually after doing this, the extracted dex file was removed from the file system, which makes it difficult for us to copy or extract it directly from the file system. So there can be different ways to dump or extract this unpacked dex file. First one is by hooking, and the other one is by dumping them directly from the memory. First, let's see how we can extract the text file using hooking techniques. As I have told you, all the protectors after loading the extracted text file into the application deletes it immediately from the file system. So let's try to hook the file.delete API from the Java layer and see whether we are able to see any references to any of the text file. And for that, let's open our Visual Studio Code, right? Here, let's create a new script. Let's name it as script.js. And here we are simply going to hook file.delete method of Java. Now, in order to perform hook at the Java layer, we need to define it under java.perform API of Frida. This takes one argument as function. By making use of Frida's java.use API, we can dynamically load the java.io.file class. Let's store it in f variable. So now this f variable contains the instance of java.io.file class. Okay, next we want to hook delete method of this class. So for that, we can access this method using f.delete, and in order to replace the implementation of this method with our own implementation, we can use .implementation and then pass a new function. And as delete method does not take any arguments, we don't need to pass any argument here as well. And now inside the body of this function, we can define our own implementation for this delete method. So first of all, we want to check for the argument or the path which this delete method is trying to delete, that we can get using this dot get absolute path, and we have stored it into this path variable. Now let's simply print out this path using console.log delete cached, and then we have the path in the path variable. And at the end of this function we need to return either true or false, because the return type of the delete method is boolean. If the function is able to delete successfully, then true will be returned, otherwise false. So for now we are just going to return true every time, and that's it. Let's save the script, open up our terminal. Let's start the Frida server on the device first by going into the ADB shell, and I have my Frida server stored under data local temp dot slash server. Alright, so now the Frida server is running on this device, and if we go back to our Visual Studio Code in the terminal, let's spawn this application using Frida. So we have Frida -u, and then we need to forcefully spawn the application. Then we need to pass the package name of this application, which is com.tilks.arsc merge. Then we need to pass our script, which is script.js, right? Let's hit enter, and the application spawned successfully, and in the console we can see that we have the logs, and in the output we can see that all these files are being deleted using this file.delete method, right? But since we have replaced the implementation of this delete method with our own implementation, so this time instead of deleting these files, it has just returned true every time without actually deleting anything. So these files should be present in the device file system at these locations, right? So let's quickly have a look. Going back to our device, let me copy the path, which is this one, and can go to this path using cd command, hit enter. Then using ls command we can see the content of this directory, and we can see that we have multitext.log here and base.apk.classes1.zip, right? And the directory name also suggests that this is the place where all the secondary text files will be stored. So let's dump this file from the device to our system using adb pull command. But before that we need to copy this file to the SD card, because currently it is present in the app directory, which is not accessible from outside. And out of these two files we are only interested into this one, because by the naming convention of this zip file we can make a guess that it might contain something related to the classes of application, right? So let me quickly copy this file to the SD card using cp base and then /SD card, hit enter. So now it's copied into the SD card. Now we need to come out of our device, and over here currently we have the APK and our script. So using adb pull, and then we need to pull it from the SD card by passing the file name, which is this one, and the destination is current directory ls. And now we have this zip file in our system, right? Now using any unzip utility we can extract this zip file. So let's quickly do that using unzip command, base apk classes.zip, hit enter. From the zip file we can see that we got classes.text file, right? So this should be our unpacked text file. Let's quickly have a look at it by opening it in the JADX. So file, open file. No, we don't want to save the project. And let's open classes.text file this time. Open. And the decompilation is done, and we can see that we got some other packages here this time. And let's expand the com package, and this time we can see that we have our tilks.arsc.main package, and if we expand it we have our main activity, merge service, and settings activity. So all the classes which were defined in the Android manifest file are visible to us now. Don't get excited yet. In some cases you might encounter situation where the protectors are not using this file.delete method, for deleting the file. In such cases, you won't be able to intercept any of these paths. Instead, they may rely on native functions such as remove or unlink. So in case if you are not able to intercept the text files, then don't worry. Try hooking on these native functions responsible for deleting the files and you should be able to get the files. So let's quickly see how we can hook the unlink function for intercepting such interesting paths. Let's create a new script for hooking the unlink function. Let's name it as native script.js. Okay. Now, in order to hook the unlink function, we first need to find its address at which the function is present in the memory. So for that, we can use module.findExport by name API of Frida, and this will take two arguments. So if you know in which library this function is present, you can pass the name of the library directly. Otherwise, you can leave it as null. If you pass null, then it will look into each library loaded into the memory for this function symbol. Then the second argument is the name of the function itself, which is unlink. This will return the address of this unlink function. So let's save it as unlink pointer variable. Okay. Now, similar to the previous one, we need to replace the functionality of this unlink function, and for that, on the native side, we have interceptor dot replace API. Okay, and the first argument that this replace API takes is the address of the function, which we have already calculated and stored as unlink pointer, right? Then the second argument is a native callback. So whenever this unlink function will be executed, this native callback will get triggered, and here we need to pass our own implementation of the function. So function, and if the function takes any argument, then we can provide here. So the unlink function takes one argument, which is a pointer to file path. So let's simply name it as path, and then we need to pass the body of this function, and inside the body let's simply put a log on the console unlink. Let's pass the path. So since it's a pointer, we need to read it from the memory, and we know that it's a character pointer, so we can directly read it using path dot read c string. Okay, and the unlink function return type is an integer, so we need to finish this function by returning either 0 or -1. So in case of the function successfully executes, then it will return 0, otherwise it will return -1. For now, let's simply pass 0 always. Then after the body of the function, we need to tell the return type of the function, which we already know is integer, and then we need to pass an array of arguments. So since this function only takes one argument, which is a of type pointer, so we can pass it like this. All right, let's save the script, go back to the terminal, go back to adb shell su and run our Frida server. Okay, and going back to the Android Studio Code terminal, clearing the console, and let's try to run the script again. Frida -u -f form this, and this time the name of our script is native script. Hit enter, and the application spawn, and this time we can see similar paths. So now we can repeat the same exercise again by dumping this zip file from this path. So let's copy the path, close the Frida server and switch to this directory. Oops, sorry, I copied the wrong one. It's here, and over here again we can see we have base apk classes 1.zip. So let's copy it to the SD card. Then we need to come out of the device shell and to our system. And over here, since we already have this one, so let's remove it first. All right. Also, let's remove the extracted classes.text. And now using adb pull command, just like before, we can pull this base.apk.classes1.zip to this current directory, and done. And we have this base APK classes 1.zip. Then again, using any unzip utility, we can extract this zip file, and now we have this classes.text. If we try to open this classes.text again in JADX, we should be able to see all the classes, right? So this is another way of extracting the text file. But still, if you are not able to intercept the text file using these techniques, then we have another way to get the job done, and that is by dumping the text file directly from the memory. In fact, you can apply this technique to dump any file or any library from the memory of a specific process. The idea behind this is that even when the file is deleted from the file system, because the file was loaded into the process, we can get the trails of the deleted file from that process. In Android, we have proc maps file to see the memory mappings of the running process. For that, first let's close the application and launch it again. But this time we are not going to spawn it using Frida. Instead, we are going to simply launch it from the device like this. Now, in order to see its memory mapping, we need to first identify the process ID of this running application, which we can easily do by going back to our terminal and going to the device shell using adb shell command, getting the root access, and then we have ps command -a to see all the running processes. But since we only need to see the process id of this particular application, we can filter the output using grep-i, and then we can pass any substring of the package name, which is tilks, hit enter, and as we can see, this is the application running and this is the process id of the application. So now we have the process id of the application. We can simply print out the contents of proc maps file using cat command /proc. Then we need to pass the process id, which is 27368/maps, and there we go. We can see all the files which are being mapped into the memory by the application at runtime. Right, it's a lot of files. So since we are only interested in the files which are related to dex, so let's filter this output again using grep command -i and hit enter, and now we can only see the output which contains dex, right? And over here, let me expand this a little bit for better understanding. And here you can see that at this memory region, it says delvic-classes.dex has been extracted in memory from /data user secondary dexes base.apk.classes1.zip, right? So by this, we can assume that this zip file, which basically contains the unpacked version of our dex file, was loaded into the memory at this memory region. And as I have already explained you that the file gets deleted once it's loaded into the application. So let's see this. If we try to access this path directly, cd enter, we notice that it says no such file or directory. So we cannot simply dump this dex file by accessing this path because it's already been deleted. So let's see how we can dump this memory region from the device. And for that, we are going to create a Frida script. So let's open our Visual Studio Code again and create a new script. Name it as dumper.js. Okay. Now, first of all, we need to know the memory region which we want to dump. So for that, we are going to store the start address of the memory region, which is this one. Copy, paste, and we need to wrap this as a pointer. Similarly, we can get the end address of the memory region, which is this one, right? Paste. All right, so now we have the start address and the end address of the memory. Then we need to calculate the size, which we can simply calculate by subtracting the start address from the end address. So end address dot subtract start address. All right, let's print out the log dumping memory region start address end address. All right, then we need to read the bytes from the memory within this range. So for that, we have memory dot read byte array API. This basically takes two arguments. First one is the starting address from where we want to read the bytes. So that is going to be start address. And the second argument is the size, which we have just calculated over here in this variable. But this function the size as an unsigned integer, so we need to parse this variable as integer using parse int size from hexadecimal. Since we have subtracted two hexadecimal values, the result of this subtraction was also in hexadecimal, and that's why we have passed 16 here. Let's store this in a buffer variable. Okay, next we need to store this buffer into a file. So for that, let's create a new variable called file path, and here we can pass the path where we want to store this buffer, and make sure that you use the app directory as your file path, otherwise you might face issues with the storage permissions. So we are going to use /data, then the package name, which is com.tilks.arsc merge, right? Then we can provide the file name, and just to make the things dynamic, we are going to use start address as the prefix of the dumped file, and then we are going to append dump.text. So this is going to be the file path where the dumped text file will be stored. Next, we need to create a new instance of file and store it under file handle variable, new file. Here we need to pass the file path and flags, which is going to be WP. All right. To avoid crashes, let's put some conditions. So if the file handle is available and it's not equal to null, then only we are going to write our buffer into the file. So now we have our file handle. So using file handle dot write method, we can write the buffer into the file. Then we need to flush it and then close the handle. All right, just for the sake of visibility, we are going to print some logs. File successfully dumped at file path. All right, so we are done with our script, and hopefully this will work. Let's clear the terminal here, go back to the device shell, cd/data local temp, and start the Frida server again. This time we don't want to spawn the application again because we have hard coded the start address and the end address here. So if the application restarts, these addresses will be changed due to ASLR and our script will not work. So we are going to use Frida-u, and then instead of forcefully spawning the app, we are going to simply pass the name of the application. Okay, first of all, let's find out the name of the application using Frida-ps-ua. Hit enter, and this will list out all the application packages along with the process IDs. So we have our application name as anti-split-g2. Let's copy and paste it like this, and then we can pass our script called dumper.js. Hit enter, and in the console it says dumping memory region from this to this, which is okay, and then the file is successfully dumped at this location. So let's copy this location, go back to the terminal, close Frida server, change the directory to this location, and let's see the contents of this directory now. And here we have our file, right? So again, just like before, we need to copy this file from this directory to SD card. Now let's come out of the device shell and onto our device. We can pull this dumped text file from the SD card using adb pull/SD card and then the file name into the current directory. Hit enter. The file has been dumped successfully. First, let's confirm that the file is actually a text file, and for that we have the file command. So if we run file command on any file, it will basically show us the type of the file, what type of executable it is. So if we hit enter, we can see that it has successfully been identified as a Delvic text file. All right, so we can be sure that the file is properly dumped and the text signatures are present in the dumped file and they are not corrupted. Now let's quickly open up our JADX and open this file, this one, open. But wait, it says load failed, and if we see the log, in the log it shows bad checksum. Alright, now this might happen sometimes when you dump any file from the memory, but don't worry, we have a quick solution for this. So if you go to the file under preferences, here you see under the plugins section, we have this verify text file checksum before load. By default, it's yes. We can change it to no. Save. And as you can see now, JADX has been successfully able to decompile our dumped text file. And in the source code, we can see we now have this com directory. Then we have our main directory, and inside this we have our dumped classes. So that's it for this video. If you found the video informative and enjoyable, please consider supporting us by subscribing to the channel and hit the like button. We would also appreciate hearing your thoughts and suggestions for future video topics in the comment section below. And I will see you in the next video very soon.